So we're going to first look at the law of sines. And what we use the law of sines for is to solve unknowns in an oblique triangle. Oblique triangle, which means a triangle that has no 90-degree angle. So typically, if we have a right angle, then we call that a right triangle. And we can use SOHCAHTOA, sine is opposite over hypotenuse, those rules. But when we don't have a 90-degree angle, we cannot use the SOHCAHTOA formulas or equations. So we need to use new ones for oblique triangles. So no 90-degree. So what that means, we could have either, if one of them is obtuse, more than 90, then the other two would be acute. Or we can have 3 acute angles. So 1 obtuse, 2 acute angles, or 3 acute angles. Like if it was a 60, 60, 60, that's an example where those are all acute angles. That would work out to that they add up to 180. So when we label our oblique triangles, we have to make sure that we're going to use A, B, and C always to be consistent. So, make that look straight. If I put angle A down here, down to the left, and then angle B on the bottom on the right side, and then angle C at the top. So notice in this case it kind of looks like the angle C is obtuse. So I'm using capital A, B, and C for the angles, and then side A needs to be across from angle A. Side B needs to be across from angle B. Side C needs to be across from angle C. We have to label it like this for the formulas to be accurate. So what we're going to do is a lot of times we might know 3 pieces of information. If we know 3 things, we should be able to solve for all the rest. So for example, we'll do somewhere, maybe I know this side, this angle, and this side. Or maybe I know all 3 sides but not the angles. So we'll look at different situations of what we can solve if we know some information. Okay, so let me give you what the law of sines actually is, now that we kind of defined our triangle. So, the law of sines is that if I have side A over sine of angle A, that would be equal to side B over sine of angle B. So, now I'm going to keep going, but this would be one of the equations that would work, but also the same ratio of side C over sine C. So we're going to use not all 3 of them at the same time, but maybe the A and C ratio, put them equal to each other, or the B and C, or the A and B. So this is actually kind of like 3 formulas in one, just that each of the ratios are equal to each other. Okay, so for our first example, this one is going to be a angle side angle. And this would be labeled ASA. So a lot of times with law of sine and law of cosine, we label them like this. This means angle, side, angle. Meaning, so for our example that we're going to do, let's say I'm given that angle A is 35 degrees, angle C is 85 degrees, and then side B is 13.5 inches. So notice, I'm going to draw my triangle over to the side. I'm going to draw it, I'll draw it kind of similar to how I did just before. A, B, C. So angle C is 85 degrees. Angle A is 35 degrees. And then notice side B needs to be across from angle B. Let me label my side A, side C. So notice that why this is angle, side, angle in that order, because I know an angle, then a side, then an angle. I kind of go around the triangle. So the side is in the middle because it's the side across from the angle we don't know to start off with. Okay, so if we know these, we're going to look for, we want to know, find angle B, side A, and side C, all the missing parts. So this one, well, the first thing to find, angle B, is actually not too hard because I know the 3 angles of a triangle add up to 180. So I could just do 180 minus 35 minus 85 and get my leftover angle of 60 degrees. Okay, so I know angle B is 60 degrees. Okay, so now that I know angle B, notice here in this, if I look at all of these different fractions, there's only one now that I know both the side and the angle, which is the B. I know side B and I know angle B. So to use law of sines, I have to know a side and an angle in one of the fractions. So that's going to be what I'm going to use. I'm going to use side B, 13.5, over sine of, oh, not B. I know what B is. Instead of putting angle B, I'm going to put in 60. So 13.5 over sine of 60. So now I'm going to set that equal to, now I can do either of these since I know angle A and angle C. Let's just do, angle A first, or the A ratio first. So if I put A over sine of angle A, which is 35, so now I can solve for A. So notice these are all, it's a ratio equal to another ratio or proportion. So with these I can cross multiply. So I'll do my cross multiplying, and I've got 13.5 times sine of 35 equals A times sine of 60. Okay, to get A alone, I'm going to divide both sides by sine of 60. Now, and I could have done this, punch in my calculator, jot it down. So depending on how you want to do it, you could do this all in one step. Just be careful. 13.5 times sine. Usually most calculators start a parenthesis. This in a different color. So if that's the case, then you need to end it, then hit divided by sine of 60. So what you should get is that side A is about 8.94. So I'm going to use a little squiggly. 8.94 inches, since we were talking about our distance. Okay. So now I know side A is 8.94. I'm going to put that over here, because then we'll kind of do a check at the end. But so far this is kind of making sense. 35 degrees. It certainly should be smaller than 13.5, considering it's across from a smaller angle. Notice I didn't really draw this to scale, but okay. So how about now let's find side C. Looks like I'm going to have to do a little erasing. I'll keep this up. I'm going up here now. So now to do the C ratio. Now I know A and B, so I could use either of those. But let's just stick with the 13.5 over sine of 60, since now my 8.94 is an approximation, so we might as well use the more accurate 13.5. So I know my B ratio. I want to know C. So I'm going to put C over sine 85. Notice I'm going back and I'm using the formula again. Sometimes you want to just jump and think, oh, I know two sides. I can find the third one with the Pythagorean theorem. But remember, the Pythagorean theorem only works with right triangles. Okay, so notice my ABC, my A squared plus B squared equals C squared. That only works if we have a 90 degree right here. So with law of sine and law of cosine, when it's an oblique triangle, we cannot use that. So no Pythagorean theorem symbol on that for these examples. Okay, so same thing, cross multiply to get C. So 13.5 times sine 85 equals C times sine 60. Divide both sides by sine 60. And if you want to pause right now, try to put this in your calculator. What you should get is about 15.53 inches, approximately again. So I'm going to go down here in my triangle, 15.53 inches. Okay, so let's kind of go around and see if this makes sense. Because the biggest angle, in this case C, should be across from the biggest side, which it looks like it is. 15.53 is the biggest side. The smallest angle, 35 degrees, should be across from the smallest side. Smallest opening is going to mean the smallest side across from it. So that kind of is a good just estimate check to see if everything seemed to work out.